Honored to present our work on future large language models for Vietnamese spoken question answering. And this work is conducted with the collaboration of Nguyễn Đức Thích, Mr. Phạm Bảo Tuấn Trung, and the Associate Professor Lê Hoàng Sơn. My presentation will be divided into four main parts. First, I'll begin with the introduction, where I will introduce about the topic. Next, I will discuss about the methods that we are proposing, and thirdly, I will talk about the data set and the experiments we have conducted, and finally, I will conclude with the conclusions. Okay, now let's begin with the introduction. So, spoken question answering, or SQA for short, is the task of answering textual or spoken question with a given spoken context. The goal of the task is to extract the answer span from the spoken context, and in our specific case, the question is in context, is in text, and the question and the context is in audio. And this task combines the automatic speech recognition errors and the question answering reasoning. So it is a uniquely difficult problem, especially for low resource languages like Vietnamese, where only few prior studies has been made. So SQA has become a increasingly active research topic over the past 5 years. Some notable studies include the spoken SWOT by Lee, which extends the SWOT dataset to the spoken domain, or the spoken code QA by Chen Yu, which creates a brand new dataset for spoken conversational question answering, and proposing the DDNet model for an end-to-end paradigm to solve the problem, or the HeySWOT dataset by Yijing, which is a large-scale dataset tailored for evaluating the SQA systems. However, most of the work has focused on the high resource languages like English or Chinese, while low resource languages like Vietnamese has attained very little attention. So our work to address this problem, our work will investigate the few-shot prompting with some current open source large language models to examine how well the current large language model can adapt to this task with minimal supervision. Okay, now let's dive into the method section. So here's an overview diagram of an SQA framework. So basically, the spoken content is processed by an automatic speech recognition to get the textual context, and this transcription will, together with the text question, will be fed to the machine reading comprehension model to extract the relevant answers, and we use the two main metrics, that is EM and F1. EM is the exact match, and F1 to evaluate this model prediction answer. For the machine reading comprehension model, we experimented five state-of-the-art models that have shown a great performance on several Vietnamese language tasks, including Phở, Bát Phở, Mở Bớt, VIT5, and XLMR. Each of these models is trained on the in a Vietnamese question answering dataset, and this fine-tuning process is essential because it helps this model to achieve a good performance, but it also requires a significant amount of training time and computational resources. Okay, so we come up with the few-shot prompting LLMs. Compared to the machine reading comprehension models, few-shot prompt, this approach requires no training but inference only. The spoken content from the test set is first go through the ASR module to get the textual context, and together with the question, it will create a prompt for the LLM, and for the prompt creation module will include three main parts. First is the task instruction to guide the model what to do. For example, you can guide the model by saying this is a question answering task and try to answer the question beyond the context above. For example, like that. And we then add the in-context samples, which is the question and answer pairs getting from the train set, and finally we append the context, the target context and the question to the prompt to finish it. And once the prompt is finished, it will be fed to the LLMs to extract the relevant answer without any further additional training or supervision. Okay, moving on to the experiment section. First, I'll talk about the dataset and the matrix that we are using. We use the VSQA dataset, which is one of the first Vietnamese SQA dataset, and it consists of over 10,000 QA pairs for training and 1507 QA pairs in the clean test set. And here are some key characteristics of this dataset compared to other most related one. And for evaluation, we use two main metrics, that is the exact match to measure the percentage of prediction that match the ground truth and answer exactly, and the F1 to measure the overlap between the predicate and the ground truth answers at the token level. And here are our main results, evaluation results of LLMs on the VSQA dataset using the 5 prompt settings. We use 5 different open source multilingual large language models, including the Mistran, Gamma, Quen 1.5, Llama 2, and Mixtang. With the first 4 models have approximately about 7 billion parameters, while the last one contains up to 13 billion parameters because owing to the mixture of experts architecture. And the results have shown that the last model achieved the best results with 41.57% on EM and 70.8% on F1, followed by the Quen 1.5 with 37 and 67% on EM and F1 respectively. The Llama 2 has achieved the lowest performance with only 32 and 63% on EM and F1. We also conduct an ablation study to examine the effect of in-context samples affect to the performance of the models. We choose 2 representative models, that is Llama 2 and Quen 1.5, and the results have shown that the increase of in-context samples leading to the consistent increase in the model performance on both EM and F1, like Llama 2 and Quen 1.5 achieved 63 and 66% on F1 when Wright increased the in-context sample from 2 shot to 5 shot. And finally, we make a detailed comparison between the LLM-based model with the machine reading comprehension-based model. For the machine reading comprehension model, we choose 3 representative models, including VIT5, XMR, and Ember. And for LLM, we choose Quen 1.5, Mixtran, and Mistral. And as you can see, as expected, the supervised machine reading comprehension model achieved better performance on the EM, with VIT5 peak at 55% on EM and 73% on F1, and the XLMR and Ember closely behind. While the LM trail on the EM, but it also have a very competitive performance on the F1 matrix, with Mixtran achieved 70.8% on F1, and Quen 1.5 also have pretty good, pretty competitive results relative to its model scale. But the cost profile between these 2 types of model is different. While the supervised machine reading comprehension model requires up to 5 to 6 hours of training, the LLM inference only models can complete the task in under 2 hours. I want to explain more about the reason why the LLM model trail in the EM. Mostly because when we train the MRC model, it will align better with the answer in the ground truth set. But the LLM, because it's only study from some samples in the training set, so it can correctly identify the correct passage or the correct sentence that contains the answer, but fail to align exactly with the answer from the ground truth set. And finally is the conclusions. So here's the main contribution of our paper. Firstly, we propose a few-shot pipeline for SQA using an open source multilingual large language models without the need for task-specific fine-tuning. Secondly, the performance of several LLMs is evaluated on the VSQA dataset and compared with the supervised machine reading comprehension model to demonstrate the competitive results with only a few in-context samples. And finally, the finding provides a practical insights for applying the LLMs to low-resource SQA tasks and highlight for future direction optimization for prompt design and domain adaptations. That also concludes my presentation. I would like to sincerely thank all the listeners for your time and attention until the very end. Thank you very much.
Thank you very much for also promising presentation in NLP and it's for Vietnamese language. So I think that this presentation needs some comment from the listeners. So any question for him?
So now, have you ever used the auto language? You study mainly you study NLP for Vietnamese language, right?
Yes.
So have you ever researched for auto language first before Vietnamese?
Yes, I have some prior works working with many others with many other languages, but because spoken question answering is a very hot topic in the world, but it attained very few prior research in Vietnam, so I decided to focus on it.
I think very challenging.
Yes.
But it may be similar to Thai language.
Yeah.
Thai language,
Yes.
and Vietnam language is like more than English or Japanese or Korean that have a lot of research.
Yes.
But we can apply the technology and storytelling for our language. So thank you very much.
Have question.
Your experimental result.
Yes.
Yeah. And can you
Explain
explain
about
about the data sets and
How
do you train these? What is the percentage
Of
of the data set that you use on the training and on the
validation.
Yes.
and, well,
yes.
the following question would be, what would be the acceptable
Standard, okay, of the test result that will be acceptable if you're gonna use it for the commercial.
The first one I want to explain is that we are using the VSQA, the Vietnamese spoken question answering and the set, and for the machine reading comprehension models, we use over 10,000 QA pairs for training, and we do on the test set including 1507 samples. But for the LLM models, we only use 2 or 5 shots, which means we only use 2 to 5 samples in the training set, and we also test on 1507 samples in the test set. And for the standard for the commercial use or the industrial use, because most of my research is focused on the research domain, but with the machine reading comprehension model, here are some standard models that have achieved many very strong performance in many Vietnamese Vietnamese NLP tasks. So we use this as the benchmark to compare with our proposed LLM inference pipeline. And that's my answer.
Okay. So thank you so much for the presentation and congratulations.